Hi friends, I am Ishtiyaq Kadir and I am going to teach you about the calculation of total number of microstates. It's a very important topic as far as CSIR net is concerned. There have been so many questions asked in previous exams from this topic. So microstates can be found for five different types of formulas we can discuss for five different types of questions which may be asked in 2018 December net. So first of all, we'll discuss how we can find the number of microstates when we are given a given electronic configuration. For example, we have P1 electronic configuration. The number of microstates can be found by using the formula n factorial divided by r factorial into n minus r factorial. Here this n indicates the number of electrons that can be accommodated in a given subshell. Suppose in P subshell we can accommodate maximum 6 electrons. In D subshell we can have a maximum of 10 electrons. This is D1, D2, this given electronic configuration. In F subshell we can have 14 maximum electrons because we know there are 7 orbitals in F, 5 orbitals in D and 3 orbitals in P. Now what's R? It's the given number of electrons in a given subshell. Suppose for P1 we have 1 electron, D1 we have 1, D2 we have 2. So it's given number of electrons in a given subshell. N is number of electrons, total number of electrons that can be filled in a given subshell. So for example, if we are solving this question P1, suppose we have an element whose valence electronic configuration is P1. For example, we can say boron. Its atomic number is 5. We can write 1s2, 2s2, 2p1. Now we can find the number of microstates. It's very simple. That's equal to n. N is number of electrons in a given subshell. We know that in P we can accommodate maximum of 6 electrons. Because we know for a given subshell P, we have 3 orbitals, px, py and pz. We can accommodate maximum of 6 electrons. So it's 6 factorial divided by, we are given P1. P1 means 1 electron is present, so R is 1 factorial into n minus R, so it would be 6 minus 1 factorial. So 6 factorial means it's 6 into 5 into 4 into 3 into 2 into 1 divided by 1 factorial means 1 only, 1 into 1 into 6 minus 1, that is 5. So it's 5 factorial. We can write it 6 into 5 into 4 into 3 into 2 into 1 divided by 5 into 4 into 3 into 2 into 1. So if we cancel these terms, answer is 6. It's very simple. Similarly, you can solve other examples to answer these questions and comment below. If you have any difficulty, you may ask. Now if we are given a mixed electronic configuration like P1D1, now we have the formula number of microstates is n factorial divided by r factorial into n minus r factorial. This is n dash. For another electronic configuration, you can write this. Suppose you may also call it n1 for P. Suppose P we have maximum electrons 6 factorial divided by given number of electrons is 1 into n is again 6 minus r would be how many electrons in P? 1. This is factorial into another is D, it's D1. So D in D we have maximum of 10 electrons, so it is 10 factorial, because you know that for D we have 5 orbitals, D subshell. One's dxy, dyz, and this is dxz, dx2y2 and dz2. So given number of electrons is 1 into we have n minus r, so it is 10 minus 1, because we are given D1 electronic configuration here and P1 here. So it's as simple as that. 6 factorial divided by 6 minus 1 is 5 factorial into 10 factorial divided by 10 minus 1 is 9. So it would be 6 into 5 factorial in simple terms divided by 5 factorial is 10 factorial divided by 10 into 9 factorial. So we can write it as 10 into 9 factorial. This and this cancels. So 10 6 are 60. 60 number of microstates are present in P1D1. So you may now go for some examples which you may answer in the comment box below. Let it be P2 D3. Try to solve this question and answer in comment box. Now if we are given a term like 3D, suppose you know term symbols. Number of microstates is given by 2s plus 1 into 2j plus 1.